Welcome to Kenton Teaches. Enjoy the video.
You begin by preparing data and selecting a model. This is where progress happens fast. First, assemble labeled images, at least 500 per class if possible, and split 70/30 for training and validation. Once done, pick a backbone. Use mobile net for edge devices or efficient net/res net for higher accuracy. Pre-trained weights save days. Make sure to set image sizes, augmentation policies, and annotation format, COCO or Pascal VOC, so the training pipeline can run without manual fixes. You now construct the training pipeline and iterate deliberately. Begin by coding a robust data loader with augmentations, horizontal flip, color jitter, and scaling between 0, 8, and 1, 2 to improve generalization. Next, configure loss functions for classification and box regression. Choose an optimizer like SGD or Atom and a learning rate schedule. Try 0, 0, 0, 1 as a starting point. Once set, train with transfer learning. Freeze the backbone for initial epochs, then unfreeze and fine-tune the whole network to converge. You finish by exporting and validating the model for deployment. Convert the trained weights to ONCs or TF-Lite and apply 8-bit quantization when edge performance matters. This reduces size and latency. Then, run the model on a held-out test set and the real device, measuring MAP, inference time, and memory. If something goes wrong, inspect annotations, confirm preprocessing matches training, lower the learning rate, or add regularization. These checks usually reveal the root cause and get you back on track.
Thanks for watching. Please subscribe if this video was helpful.